Hello. So I want to make a video for swap tile and check when. I sort of did swap tile already. So I just left it there. I don't want to retype it. But I think this is going to work. So we'll see if this works or not. But basically, this is sort of the classic swapping algorithm. I suppose one of the things that you have to understand here is that, like, when you swap the tiles, right? Like, you have the blank tile, and then you have a location which is holding a value, and what you want is that location that had the blank tile to have the value, right, that you're swapping, and then you want the location that was holding the tile value to now be the blank spot, right? Sort of switching the values. Of course, you're always switching it to blank. I mean, so I'm saying temp equals board blank row blank column. I suppose you could get away with just saying like the board tile, like sort of the location that the tile used to be in is going to be 0 because that's always like the blank value. So I guess you could have got away with that. I guess you really don't need a temporary variable. I guess you could have just had this line here and then said blank or board tile row tile column equals 0. That would probably work because it's a static value. But this is a great opportunity to talk about this temporary algorithm. And so we could hold on to the value which is being stored in the board blank row blank column. We could then overwrite what that value is in that location and set it to the value being held in tile row tile column, and then we could set the value in tile row tile column to be the temporary value that we held on to here. Notice that the value that we had here is like overwritten in line 2, so it's like no longer there. So we could kind of see if this works at this point. I do have check when in there, so let's go like this and just go past so we can see if we can play this game. And I think I took out a piece of code here. Display board because I can't see my board. All right, let's try this now. Boom. All right, there it is. And so what happens if I push straight? Oh, whoopsie. What happens if I push straight? It's swapped. Right? What happens if I 4? It's swapped, right? 7, swapped. Let's try an illegal move like 8. Oh, 8's not an illegal move. Let's try an illegal move like 2. Not a valid move. Not a valid move. And so then if you watch the video, I think I put in like, maybe I didn't quite like this. I think I put a border into this, which if you want, like in the display board, I kind of said I might like to print out, because there's about 3 spaces for every character, right? So let's try this. So that's kind of like a border. This can give us a little border action. Yeah, that's pretty good. Maybe like 1 extra spot, but I'll live with it. No, it's kind of 1 extra spot over there too. Well, and sometimes doubled up. Yeah, no, I'll live with that. And then I think it does make the game like a little easier to deal with, or at least more aesthetically appealing. So the last thing you have to do is think about checking for win. Well, checking for win would mean that I get 1, 2, 3, 4, 5, 6, 7, 8, right? And then I get the blank spot, which is actually the 0, right? The 0. So what I really need to do, I think this is a nice pseudocoder, is I really need to be able to iterate through the board, right? And check, so let's just say iterate through the board. Check each value to see that it starts at 1 and increments by 1 as you go. Now, technically that last spot should have a 0 in it. Okay, but I'm going to make an assertion here, which is that I don't actually have to check the last spot. because the last spot, if everything else is right, that last spot has to be right. So that's kind of an interesting idea. So that's still not quite so easy because we're talking about a double for loop iteration, and so I think I got this. So I'm going to iterate through the board. I'm going to try to iterate through the board. Let us say that. Let's say that it's got to be similar to this, right? It's got to be pretty similar to this 5. Iterating through the board. We've done this many times. So let's figure out the length of the board because that could vary. We're going to iterate rows, columns. Okay, so board, row, column. And I have to check out to see like what this was. So do you agree that the first value is supposed to be 1? The first value I'm checking to see is 1. And I suppose, okay, let's say if it's not equal to count, I can return false. I kind of like that idea. So if it's not equal to count, I can return false, right? Then I'm going to have to say, okay, if I get past that, I'm going to make count be 1 bigger, right? And so next time it'll check for 2, 3, 4, 5, 6, 7, 8, okay? The deal is when would I know that I've sort of made it to that second to last spot? I actually don't have to make it to the last spot, and by the way, that's going to be sort of a different check because it's 0, right? So how would I know I've made it there? How do I know I've got to that max value? Well, hopefully you understand that the max value is going to be n times n minus 1. Do you agree? N times n minus 1. So in the case, let's think of this board right now that we've got. Is the n value is 3, right? Like the board is 3. The max value is going to be 8. So you agree if I'm stepping through this two-dimensional array, right, and I see a 1. Okay, fine. If I see a 1, I'm going to skip that board, row, column not equal to count, right, because it counts 1 the first time. Then count becomes 2, so the next time like it would have to be 2, the next time it would have to be 3, the next time it would have to be 4. If at any time it's not what I want it to be, I'm going to turn false, boom, okay? So the question is, did I ever get to a point where count was this max value? Like I actually checked it and it was like an 8. I checked it and it was an 8. Where would that moment be where, let's say I checked it and it was an 8? That would be right here before increment count, because now count would be 9. So I mean I could put it after, but so bottom line is I'm going to say if I get to a point where max val is equal to count, I am going to return true. It may not like this. You know, I'm gonna argue that no matter what, I'm gonna make it through this thing, but it might not like this function because it might be telling me like it's not always going to return something. I suppose if somehow I were to iterate through this whole thing and never return false, I feel like I'd want to return true, but I should never really make it to that line. But it does sort of put something in there, maybe, which tells Python that no matter what, because these return statements are kind of inside these if statements. And sometimes like it'll tell you, oh, like you don't really have a return in all cases sort of thing, or maybe that's more of a coding method. So let's just go ahead and run this thing. I don't know if do we really need this? Let's see if we really need this. Okay, we don't really need it. They didn't really make us sort of do it. Now I could try to win this game, but this is not like the easiest game to play, and I feel like I could win it, but it's a little tedious, a little frustrating. So here's what I'm gonna do. I'm gonna say, let me set up a board let me set up a board that is done. That's perfect. So I'm going to get rid of this. I'm going to take a look at board. I'm going to grab this array. And I'm going to come up here. And the place to do it, where's my attendance? The place to do it would be here. Like, I mean, I could comment out this make board in this case and say I don't want that to happen, or I could let it happen. But I'm just going to overwrite that value of board, and I'm going to set it up so that I get a win, right? So what's a win going to look like? It's going to look like 1, 2, 3. It's going to look like 4, 5, 6, 7, 8. And then 0 would be over here. So that should be a winner, winner, chicken dinner. And I don't know. So I put 1, it said not valid move, it said yay. So it is checking to see that I won. Now, the way that the sequencing is set up, like there's always going to be this first like sort of prompt for a tile. I mean, because we're not ever expecting it to be done, upon, we're not expecting it to be done like right away. So we're always expecting someone to have to make a move, right? So that's not going to be a thing, but you can see that once it gets into that while loop and checks it, it sees that yay, like we won. So that actually does work. That check run. Now I could maybe say, well, does it work for a 4x4? I don't know. I should probably try that. I could try that, but I feel pretty good about it. I feel pretty strong about it because I made everything in terms of variables. I didn't put any numbers in there like 8 or 15, and I'm putting specific explicit numbers. Everything's in terms of variables. Everything is relative to the length or size of the board. So I feel pretty good about that. That is that. And I'd probably take this out now and just allow myself the ability to sort of play the game and mess around with it and see if I can actually win on my own, right? But anyways, yeah. So hopefully this video has been helpful. Hopefully you've been able to kind of follow along as we go, and you're ready now to move on to doing something like this on your own, which we'll talk about tomorrow.